Join the battle to defend science. Get your copy of my book today. Topics include evolution, the Big Bang, flat Earth, young Earth creationism, and more. If you don't debate and just want to learn science, the book is also perfect for you. Check the link in the description or go to bookbaby.com and check out their bookshop. Kindle readers can also get the book on Amazon.
Planet Peterson, I think, is talking to you.
Yes, I'm not sure. Sometimes my mic goes out. Yes, that's what I said. Planet.
Okay. The problem is you're using the wrong math. So when you talk about a tangent drop, what that means is you have a circle and you draw a line that is perpendicular to the surface of the circle, I guess, and it touches the surface of that circle in one spot or sphere, doesn't matter, and then it goes off straight. Here's why that's the wrong math. That is not how we make observations, because if that tangent line is touching the Earth, what does that mean your observer height is?
0.
0. Do we make observations from a height of 0?
No, so the math actually accommodates for that. So if I'm at a 6-foot observer height, it actually accommodates and pushes it out to 3 miles instead of 1.22, whatever.
8
or
inches
0.
per mile squared doesn't do that.
Yeah, it actually does.
It doesn't. 8 inches per mile squared
No.
will only tell you the drop. You'd have to add
Right.
some extra stuff to that.
Right.
But
But
if you're going to do
I
that,
think you
just
missed
use
what
an
I
Earth
said.
curve calculator.
Yeah, the Earth curve calculator actually calculates for my observer height. You can put that in,
Yep,
which is
use
going to
that.
push the tangent out farther to where it meets the curve. Like it's
Yep.
it's the right math. I'm sorry, but it is.
No, it's not. So, because when you're saying, well, based on 8 inches per mile squared, there should be X amount of drop per Y amount of distance, whatever. Yes, but that's not how we make observations. If I put my head on the ground, I can't see something that is, my horizon is obviously going to be different than somebody who is standing up. So it's never going to match. People use the 8 inches per mile squared thing to say it should have this much whatever concealed behind the curve, but we can see it. Yeah, I can't see what my neighbors are doing in their yard if I'm not standing on a ladder because we have a fence.
Planet, respectively, we know this.
Respectfully.
Respectfully, we know this. I know that if I'm not at 0, 0 vector, that it pushes the line out of the horizon a little bit farther. If I go up to 6 foot, that's calculable.
Yeah,
And I
well,
can Google
don't use
this in
8
the
inches
Earth
per mile
curve.
squared then.
It still equals 8
Exactly.
inches per mile squared.
No, it doesn't.
It
That's an observer height
does.
of 0. That's exactly the point he's trying to
It
make.
does. We're calculating that and we're pushing the curve back in farther, right?
No, you're not.
Or
When you use 8 inches per
wait.
mile squared, you're not doing
Let's listen to what I'm telling you, please. At 0, 0 vector, I see nothing. Would you say that?
No, you could see something that is, for example, something that's 10 feet away, that's 100 feet tall. You'd be able to see
Right.
it.
So
Something that
now,
is 1 inch tall, 10 feet
now you're
away, you would
adding
not be
things
able to see it.
above the. Now you're adding things above the 8 inches per mile squared. I'm talking about
No, I'm
just the
not.
line of the circle. At 0, 0 vector, I see nothing, but nothing. I see nothing. I literally have to go up.
No,
Otherwise, I see a straight line. At a 0, 0 vector, I see a straight line.
literally
Hey,
not
Legend,
true.
real quick.
You'd be able to see a
I'm
tree
just
that's only 10 feet in front of you.
Legend. I'm just curious. What is it about 8 inches per mile square that is it just? Do you feel like the math is just simpler for you compared to other equations that we can use to show some type of curvature on the Earth?
No, we're literally talking about how you define the parabola or the circle or the drop or the curvature, right? Just on the surface of the circle is 8 inches per mile squared.
No.
That's
So
not
I
with
can.
No,
not with. Hold up one second. I'll let my point. not without going up over 0, just on the surface, not with any trees or topography or anything of that nature. Just the geometry is 8 inches per mile squared. Yeah.
No.
So
No.
I can use something a whole lot better than 8 inches per mile square, and I can get you the distance between 2 points on a sphere that doesn't involve a drop on a tangent, drop from a tangent. It'll do a whole lot better because, as you know, if you're trying to do some type of horizontal tangent drop and your face is literally stuck on the ground, as far as you can actually go is like you'll have to do just the radius, which means you only cover like
Okay.
a quarter of
Okay,
the.
cool. Cool. I agree with you. At 6 foot of sober height, 10 miles, how do I determine what I should see?
Use an Earth curve calculator.
Yeah, and that's exactly what I did, which is 66 foot.
That's 8 inches per mile squared right there, which
It's
again assumes an observer height of
you're
0.
telling me that that's not right. You're telling me that's not what I can use. So
Literally, somebody
I'm
go on a
asking you.
computer, type in Earth curve calculator,
I'm
put
asking
observer
you
height of
at
6 feet, and
6 foot.
somebody tell us what it actually says so we can address
At
what you're
six
saying.
foot.
The point is, when you say 8 inches per mile squared, everybody should just automatically stop listening to you because that is not how anybody makes any observations. Nobody is,
I'm asking
I mean,
you what math.
it's how
That's
people
not
who
right.
are five
I'm
foot
asking you
11 make
what. How do I
observations, but
determine?
for people that are 6 feet tall, that's not how it works. If
Okay,
you're
It
so
five
also
foot
comes
11,
from the
you're only this
Zetetic
tall.
Astronomy Flat
I'll
Earth
give you
Bible.
that. It's going to extend it out a little bit more. But are we like? Can I use an Earth curve calculator to determine what I should see in the drop? If not, tell me what I should use.
Use an Earth curve calculator.
All right.
If you can take in like observer height and standard refraction, then yeah, I'd say you can get a pretty good approximation.
What I'm telling you is that
I
flat
think.
earthers are using a Earth curve calculator and seeing past what they should see.
Well,
It's that simple. I mean, I don't know what to argue here.
and I think the issue is because when I give flat earthers other ways to measure Earth's curvature that doesn't involve drop from a tangent, they get upset and it was like, well, that doesn't work because that's beyond observations we can see. So at first is we can see too far, and then I give you long distance measurements, and they say, well, no, like we can't see that far. But then for some reason, it gets you from point A to point B pretty accurately, right? Like for example, an arc length, right? All an arc length is just taking the radius and sweeping it across 2 points on a circle or a sphere, and you can measure the angle between them. Now, if you know the distance between point A and point B on that circle or sphere, then you can calculate exactly what the angle difference is between them, and it doesn't involve an arc, a drop from a tangent. So that's one way you can measure curvature, because if either Earth is topographically flat or it's a sphere, we can actually get these distances a whole lot more accurately than if we use 8 inches per mile square.
Mhm.
The problem I have
And this is not to sidetrack because I like the conversation y'all have going, and I'm kind of doing work, so I'm just kind of in and out. But it's just kind of weird when we start thinking about like the specifics of the numbers and like fine tune it down to the fucking inch, even though the atmosphere is crazy, all that shit. But whatever. Why would things drop below the horizon at all? That's what I ask. That already alone tells me Earth isn't flat. I don't care if it's 8 inches per mile squared or what the fuck ever. I don't care if it's a goddamn ellipsoid, whatever it may be. Why do things go below horizon at all? That's all I wanted to say.
Oh, yeah, the existence of a horizon completely debunks the
does.
Earth
No,
being flat.
Nava. I've heard you make this argument many a times. I've seen Gene ask you numerous times, what is the drop? What should I use? You keep saying you have this ability to give the better drop, but you
I've
never
already
give any numbers. So as a
time
true
out.
person,
Use
hold
an
on,
Earth curve
hold on.
calculator.
I listen to
We
you.
Hold on.
told you three
Let
times.
me finish. Let me finish, and then I'll let you talk.
You are
But you
finished. The
being
answer
correct.
is
Hold
use an
up.
Earth curve
Hold up.
calculator.
Hold up. Did you just say use the
Yep.
planet? I'm
Use an
talking
Earth curve
to Nava.
calculator.
But
Okay, well, that's what they're
legend,
doing, and it's not coming up
No, they
correctly.
are not. You're
Guys.
using 8 inches per
legend,
mile squared.
you would be
They're
incorrect because
literally
I
using
went
the
over the
actual
math.
calculator.
I've given numbers and I went over the math numerous times with Gene. I've also did it with you. that day that you got mad when I went on the whiteboard.
I listened to you talk for quite a while. Again, how do I use your information, your knowledge, your expertise that you have, your best ability? How do I make a measurement? How do I judge what it should drop? How do I see the curve? How do I use it? At 10 miles, what should I be looking for, Nava?
Hold on,
By
hold on.
not using 8 inches per mile squared.
Yeah, go to.
So hold on. I can
Literally.
do this again for you, Legend. I did do this live. I drew it on a whiteboard, and I can do it again if you
It
need me
should be
to.
a simple answer, yet you still have not answered.
Well,
What
hold
should
on.
I be looking for when I put on water that's a mass body of water, not an ocean that has swells and waves? But
So you're changing the topic. So
I got the
I'm
answer,
not
guys.
changing the topic.
no,
I
At
got the
10
answer.
miles, you're
Go
saying
ahead,
you
Mike.
have a better reference for what I should see. I'm
Okay.
telling you it could be
Go ahead,
about
Mike.
66
Go ahead,
foot.
Mike.
And I have experience doing what he's asking, so I will answer. You find a lake that's got more than 5 miles observer distance, right? You take a theodolite, set it right up on the beach, right by the water. Measure that angle that dips down to that horizon. You can predict that angle using Walter Bislin's Earth Curve calculator, or I can show you how to do it right now with a calculator and a piece of paper and a pen.
That would be great because, a lot of the flat earthers accuse me of being very like self-centered, and I think I'm this genius, which I'm absolutely not. Especially when I look at the Walter Bislin's Earth Curve calculator, I'll be 100% honest. I don't know what half of these numbers I'm supposed to put in are.
I can show you. I can show anybody. I could do a
Thank you,
live, and I
Mike.
can show you guys how to use that if you want. I put it out there a couple times. Nobody takes the offer, but once you get the hang of it, it's pretty easy. But I could do hidden height. Ironically, it uses the 8 inches per mile square after the horizon. So you got to calculate the distance to your horizon depending on your observer height, and then anything after that is 8 inches per mile square. So that thing keeps coming up. You just got to know how to use it, and I know how to
Now,
use it.
I have a target distance of. Oh, I'll shut up.
Yeah, you could give me numbers, and then I could show you. So 10 miles, right, Legend?
Hold up, Mike. You know I love you, right? We had a good
Yeah.
conversation.
Me and you are good, Legend.
Yay.
Yeah.
All right, so planet.
Okay, wait, before you go, I'm so sorry. Before you talk, I am Legend. I put in our numbers. You said 10 miles away, there should be 66 feet of drop, right? With an observer height of 2 meters, with an observer height of 2 meters, approximately 6 feet, you're only hiding 9 meters. So observer height comes into play, and I don't think you guys take that into account as much as.
No, I'm
See the
saying that
huge
they
difference
literally
between 66 feet and
hold
9.
up,
What was it?
hold
9
up,
feet?
hold up, hold up.
9 meters. Oh,
Saying
thank you.
what I'm trying to tell you
Love
is
you.
that these people that are taking these as observations are putting in to the Earth curve calculator their observer height, their distance, and are seeing past that distance. It's that simple.
Mike, I'm so
Yes.
sorry. Are you or are you not doing these measurements?
Oh, I'm doing measurements. I'm calculating the hidden height on 10 miles, 6 foot observer right now. I'm almost
Because
done.
I Am Legend seems to think that you've been taking these observations and you're seeing further than you should.
Oh, I haven't,
Anyway.
I haven't experienced that yet.
Mark was, I said, flat earthers, the ones that you guys are battling, are taking observations and seeing past what that curve calculator tells them they should see.
Such as?
Such as P1000 at a 7-foot observation height, taking a 14.5 mile distance and seeing a 6-foot road with a car running across it and lights.
Okay.
Like,
He's not seeing the car. He's seeing the headlights.
right, but that's really representative of the car.
Well, it's not. He will never show you the car because he can't.
Yeah, he can't show you because his utensils or his instruments can't tune that in, but you can see the lights going across. You can see the lights across the road. I mean, you can
Yeah.
see.
You mean the
seeing
glare
cars.
from the lights?
So here's the problem with lights. Lights expand. So It
Yes.
catches over the curve of the Earth, and you see them.
No, only if they're directed towards you. This is directed at a 9-degree angle from you, so you don't get to
Okay.
use that one.
Okay, so here's the thing. We disagree respectfully, okay? So what I would like to do is I would like to take my theodolite down there, and I would like to take a measurement to that radio tower that's right behind that scenario right there, the McDonald's right there. There's a 300-foot radio tower, and with a 15-mile range, I've done the math. There's going to be 150 foot of drop, and I can tell you what that angle is going to be on a flat Earth, and I can tell you that on a curved Earth it's going to be a little lower, and I could go and take a measurement, and I can predict what's going to happen due to my past experiences. But I got to be honest, I haven't done it yet, but I would really like to.
So I can tell you this right now. P1000, if you talk to him, he'll fucking put you up. He'll take you out there. He would love to do that with you. And you.
Well, unfortunately, yeah, but you know what? Yesterday he left a comment saying I'm a pedo, so I kind of don't like the guy.
P1000's a cowardly sack
I
of
don't know how to
shit.
get
I've
back.
talked to him before too.
He's kind of a toxic guy. So I would never say that about you, and I would never say that about him. But you know what? He's grouped me in there. So that's the kind of people that I'm. That's the kind of shit that I'm dealing
Mike,
with these guys.
Thank you, and I'm so sorry he made that allegation against you because I am legend. There seems to be videos circulating around flat earthers that I am because I have a spiral tattoo. So we're dealing with things that are like people are making horrible accusations against people like me or Mike.
Me.
I mean,
Blue.
So
how are we
guys,
supposed to take this?
I'm so sorry. And
yeah, no worries. You don't have to apologize for him because you're good with me.
Me and you have talked, and we have great communication.
Yes.
I
No
just
worries.
Say
That's between me and him. That's not. Okay.
We all get into our own emotions and thoughts and feelings, and we all. I mean, don't try not to judge anyone. Just give them a chance.
Yeah, I try. Trust me, I try. So the good news is I'm going to the Black Swan tomorrow. I'm going to measure what I can. The bad news is I don't have the heights of the platform or the big crane on top. So it's the information's out there in PDF from what Baron told me, but I don't have that information. But there's islands back there, and I'm just gonna collect a bunch of data and see what happens. So I invited the Duke of Dropity and Area 51. So if any flat earthers want to meet me out there, I'm gonna be at Santa Claus Beach. And I'm going to be taking measurements of anything I can out there at the Black Swan.
And that's up to you. Go live for that, Mike? Mike, keep doing what you're doing, man. Just keep.
Thank you. Appreciate that.
Stay on the fucking ground. Keep doing what you're doing, man.
Yeah.
Mike, can you go live for that?
I'm going to. If I got a signal, I'm going to go live.
Beautiful.
But how far is the goalpost going to move when you figure out that there is curvature?
And I'm leaving here at midnight or 1 a.m. It's a 5-hour drive, so hopefully I'll be there at 6 a.m. setting up my theodolite and rocking and rolling. So we'll see what happens, guys.
So you're going to assume the Earth is a sphere, and then you're going to measure spherical measurements. Nice try.
Actually, Planet, I'm going to assume that it's flat. Right? I'm going to assume that it's flat. So they're telling me it's flat. They're telling me it's a sphere.
Idea. Yeah.
Right? So there's two models, and I'm going to make predictions based on two models. And then I'm going to take a measurement, and I'm going to yeah, I know what you're doing, but I'm just saying, just to be clear to everybody, I'm going to look at my measurement, and I'm going to have to go with the data on what it says. It doesn't prove anything. I'm just taking measurements. And I will be using 8 inches per mile squared to calculate some of these angles that I'm going to be measuring.
I just want to give some credit where credit's due. For everyone in the chat who doesn't know, Mike is a self-taught guy doing this. I know you got help from Baron and whatever else, but this is ultimately it comes down to you.